In this question, you have a series circuit with R, L and C given, and the resistor, inductor and capacitor are attached to a 12-volt battery. So we plug these into the differential equation and we get this, and divide through by 2 and you get this equation. Now to solve this equation, we start by solving for the homogeneous problem first, and so you get the auxiliary equation m square plus 12m plus 100 equals to 0, m plus 6 square plus 64 is 0 by completing the square, and m is minus 6 plus minus 8i, and so you get QC is e to the power minus 6t C1 cos 8t plus C2 sin 8t. To find QP, I let QP equal to A. This is because the input function here has the form of a constant, so QP has to be a constant as well. So then we get QP prime is equal to QP double prime is equals to 0, and we substitute these into the differential equation. And so we get these two are 0, and so 100A is equals to 6, and so A is 3 over 50. Now Q is QC plus QP, and so e to the power minus 6t C1 cos 8t plus C2 sin 8t plus 3 over 50. Now to obtain C1 and C2, we need to differentiate this. We apply the product rule here. C1 cos 8t plus C2 sin 8t plus e to the power minus 6t 8 minus 8c1 sin 8t plus 8c2 cos 8t, and now we have Q0 is 0.001, and so C1 plus 3 over 50 is 0.001, and so C1 is minus 59 over 1000. Now Q prime of 0 is 0, and so minus 6C1 plus 8C2 is 0, and so C2 is minus 177 over 4000. Now we have our equation. Q of t is equal to e to the power minus 6t minus 59 over 1000 cos 8t minus 177 over 4000 sin 8t plus 3 over 50. Now if you try to draw a graph of this equation, you will get a graph that looks something like this. Okay, and you find that this part is the transient part and this part is the steady state part. And so as t gets larger and larger, we find that Q of t will approach 3 over 50 coulombs. Now to find the current, all we have to do is differentiate Q, and you will get this. After some simplification, you will get this. You can try this out for yourself, and this is the equation of the current.